We haven't discussed anything from here, right? No, nothing at all. Okay, let's go through each and every one of these questions together, and then we will move on to transformers today, guys, which is the last of your electricity chapter already. Okay, if you look at the question, a student turns the handle of an alternating current generator and the coil rotates. Obviously, this is the handle here, right? And these coils will continuously cut through the magnetic field. There is an alternating voltage output between the two terminals. Voltage is otherwise known as EMF also. And then I ask you, explain why rotating the coil produces an output voltage. This is essentially explaining which concept? Which concept are we explaining here, guys? Yeah, electromagnetic induction, right? And the keyword to electromagnetic induction is that we always cut through the magnetic field. Very good. So explain why rotating the coil cut produces output voltage. You're supposed to say something like, as the coils cut through the magnetic field, EMF is generated. Wow, that looks a lot like all trims. But then once again, I've mentioned multiple times that it may seem that this sentence is very short and it doesn't deserve 3 marks, right? But if you look at the mark scheme here, it is literally everything that I've already mentioned. Mentioned electric magnetic field, mentioned the coils are being cut, mentioned EMF is generated, and bam, you get the 3 marks. So once again, I want to emphasize that the marks don't really matter. Write down what you know most of the time is good enough already. And I've also mentioned this multiple times. The marks sometimes don't justify the answer. So once again, write down what you know. Sorry? You can say produce a current, but that would not be awarded your marks because always remember EMF comes first before current mark, right? So in this question here, they only ask why is there a voltage. If let's say they ask about current, then you have to mention EMF, which drives the current in the circuit, right? But they stop at voltage already, which is EMF. So no need.
There's 2 points.
What?
Schema question.
Did you not hear what I just said? Bro, I just said that it doesn't matter because even though it may seem like it's just 1 point, but they actually separate it into 3. Magnetic field 1 point, cut through the magnetic field another point, and then EMF another point already. Okay, so you just say that as the coil cuts through the magnetic field, which I've mentioned the 2 points in mark scheme, right? EMF is generated the 3rd point, then you get 3 marks already. Okay, once again, I want to emphasize that the marks don't matter right now what you know. Okay, state the position of the rotating coil when the alternating current is at maximum value. Explain why the maximum value occurs. So you're supposed to mention, guys, in terms of the position of the coil, it will either be horizontal as shown here. Look here. It will either be horizontal as shown here, or the coil will be vertical, which means to say it will be rotated 90 degrees. So in this scenario, when will the coil generate maximum voltage? Horizontal or vertical? And why? Good. It's definitely when the coil is horizontal, it will generate the maximum voltage or current. Why? Very good. That's the keyword. You must mention that the movement is perpendicular against the magnetic field. The movement of the coil is perpendicular against the magnetic field. So you're going to say that when the coil is in the horizontal position because it cuts through the perpendicularly. Okay. Yes. And then you get your 2 marks. Statement 1, horizontal, explanation, because it cuts through the magnetic field, 2 marks.
This is one question. I have to be my question.
Yeah, I know, right? But once again, I've mentioned this. Sometimes in my head, I always think that when the guys came up with the mark scheme, right? Then they say, no, sorry, when they came up with the score, then they realized that, hey, shit, all these questions don't add up to 80. Let's see where I can add in one more mark, one more mark, one more mark, one mark here. So you always see questions that don't deserve 3 marks or 4 marks, but it's 3 marks and 4 marks. Which, once again, I want to emphasize that it's not important. Okay, then next, this one here. So basically, if you look at this question, figure 9.1 is a sketch of some of the apparatus found in a science museum, which was once used to show how the electric energy can be converted into kinetic energy, right? Which is essentially the working principle of how a fan rotates, right? The electrical energy supplied will convert it into kinetic energy that spins the fan. When the switch is closed, the wheel starts to spin, and straight up the bat, you notice that this is a DC supply. So which hand are we supposed to use? Left or right? Left hand or right hand? Huh? Which hand are we using? Yeah, we're finding for. No? Well, we're finding the current. The DC supply already provide the current, right? So left hand, huh? Because left hand is to find the force when it's a DC motor, guys. Right, and explain why the wind spins when the switch is closed. So you're going to say, guys, the whole concept of why this thing will spin is because there is a force, right? You can work backwards, guys. You can think about it backwards this way. It says that why this wheel turns, right? The reason why this turns is because there is a force, right? Why is there a force generated here? Because of the blah, 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 blah. It's because this current generates a magnetic field which interacts with this magnetic field, right? Right, so you're supposed to say something along those lines. I say that as the current flows past the, what's this thing called again? The metal spook wheel, it generates a magnetic field that interacts with the magnetic field from the permanent magnet, generating a force. Okay. As the current flows through the metal spool wheel, it generates a magnetic sorry. What is it? Look, he's on time to watch the recording later. Sorry, what do you say? Yeah. Sorry, what do you say? Forget it. Okay, then after that, which direction is this thing spinning? Clockwise or anti-clockwise? This wheel. Is it going to spin clockwise or anti-clockwise? What do you write? How do you get clockwise? Show me a hand. Yeah. Wait a minute, like this, pointing to yourself. Why is the current pointing to yourself? How? Anyone here besides him says it's clockwise? And for those who say clockwise, that is wrong. So how? Which one? Why? The current should be down like this, right? And the magnetic field like this, right? Then you should have a force in this way, Namo. Right, which will cause it to spin in this direction instead. Everyone got that? Anyone? Yeah, if you don't know, you better ask. Okay, then after that, bottom here, draw a label diagram of a DC motor. Very easy lah. Just draw the battery, draw the split ring. Alright, and then chip. Chip. And draw the magnetic field. And label everything. Battery or EMF, then split ring, then magnet, then coil. Shut up lah.
3 and 6 packets attention. No. Yeah.
My drawing is a bit ugly, guys, but you could have referred it in this diagram here, guys. Like this one here, a simplified version of this thing here. So if you cannot understand my drawing, please refer to the notes.
Okay, it's still beautiful in my eyes. Finding harder.
Yeah, good. Okay. And describe what a split ring is for. What did I say it's for again? Rotate the direction of current every 100 degrees. This question is very commonly asked, guys. You better remember the definition for this. Like, always ask in your exam if they were to ask. Okay. Next. What's this thing called? Obviously a split ring. And this one is obviously a carbon bright.
We have to mention carbon.
I think the exact brush. But I would have written carbon bright. Okay. Then which one is north and which one is south and why? How many say it's north, by the way? Can I have a show of hands of X being north? 1, 2, 3. So 4 of you guys is south, is it? Or you guys didn't do? Are you south? South. Wait, south. Oh, sorry. Oh, shit. X or Y, sorry. Can I have a show of hands of X again for the first one? X. So all of you guys are Y, Why? Oh. Why? Tell me why. So this is, which hand should we use for this one? Justin, left or right? Left or right for this one? Right. You left or right? Left. You left or right? Left. You left or right? You It's supposed to be left hand, Justin. Why? What the hell? You have no idea. What do you think this is? The first question you ask yourself is, oh, it's DC, right? So it means to say you're provided the what? The current and the zero battery, or for sure is current. right? And this will definitely be the magnetic field, right? It's either to the left or to the right only one, right? Alright, yes or no? Yes. Alright, so it's definitely the left hand, first things first. So which side of the coil do you want to look at? Okay, your mom messaged me and said that she was a bit late. Please take a seat.
Why did she come under the Charles? And Charles left 30 minutes ago.
House is just here for a fun time, bro, not a long time. Okay, anyways. Then after you know it's left hand already, right? We should look at either one side of the coil only, right? Either this side of the coil or this side of the coil, right? Because this side the force will be up or down. Okay, this side the force will be up or down. This side will be up and this side will be down, right? Because it's rotating in this direction. Yes. Okay. Then if I look at this direction here, I know that the current will be flowing like this, like this, like this, and then like this, right? Then it's essentially just aligning everything only one. But use your left hand and show me. Use your left hand and show me. Where? Which direction should it be? North? Should X be north or south? Yeah, it's pointing to your right, right? It's supposed to point to your right, guys, with reference to this screen. You know the force upwards, right? The current coming out of the screen, right? Then your magnetic field should be with reference to this, pointing to your to your right, right? It should be pointing to your right, right? Hey, I didn't give you the book yet. Oh. Oh, wait, I print the power last week. You're a guy.
Very depends always said me. Even if you buy the exact same basis of something.
No, because it's
Good. Seriously.
but it's even a kind of low, right? So it actually have a very low. It's because it will be it's longer.
So I'd say more.
Sorry. That. And then breakfast. We had meeting at 11 o'clock. Okay, say no more, fam. Okay, so from here, I know that the magnetic field is going here, right? Then obviously this must be north and this must be south, right? Yes. You really understand or not? Right, so obviously X should be your answer. This scenario. So you also are with the. You understand? State 2 changes that could cause the motor to spin faster. What is it? Okay, I could increase the current supply. Sorry? Yeah, I use a stronger magnet. Or I could increase the number of turns on the coil. Either two is acceptable. Either increase the amount, the magnitude of the magnet, use a stronger magnet, or increase the number of turns in the coil. Charles, I see you have not do the work. Charles. Okay, then after state the effects of on the motor of reversing the connection of the battery. What's going to happen if I reverse the direction of the battery? Right now, instead of this side being positive, this side is the positive right now. What's going to happen to the motor? Yeah, it will spin the other way. Instead of spinning clockwise, it will spin anti-clockwise. The motor will spin the opposite direction, or you could say the motor spins in the anti-clockwise direction, or however way you want to structure it to say that it's basically changing direction now. Okay. And finally, the battery at 9.1 is replaced with a resistor. Right now, the coil is being rotated by an external mechanism. State why is there a current in the resistor? You guys know what's happening here? They say that this battery is replaced by a resistor. And right now, this coil is being rotated externally. Why is there a current? Say that again. Why would the coil have a magnetic field right now? Yeah, I'm moving it externally.
Current being generated when
Due to electromagnetic induction, guys. Hey, remember the word they will always be asked on this. Hey, listen up, but there's no current here before I rotate it. Why? Because right now, this whole scenario here is that this thing is replaced by a resistor, so there's no current flowing here. I am generating the current that's flowing here by rotating this. And if I'm rotating this, it's basically meaning to say that the coil is cutting through the magnetic field, right? Which is once again an application of electromagnetic induction, guys. It's always asked in that scenario. You have to know as soon as in any way you're cutting the magnetic field, then you're generating the current, which is exactly what you're supposed to say here. Sorry, what? The coil has a magnetic field after the current is generated, but there is a current generated because the coil is cutting through the magnetic field first. Yeah, the coil, because I'm rotating it externally, right?
current generated by the external mechanism generated here and update the magnet.
Yeah. But you could simplify it and say that as the coil cuts through the magnetic field,
Is good. I think this is the only factor with the money. It's what? Very Charles. They have a problem with the US battery man one failure. Ebola is bad.
okay, guys, shut up and move to the next. Let's do the next question. Hey, shit, where am I? Oh, here. Okay, so right now it says that the coil of the wire is rotating steadily in the magnetic field. In a permanent magnet, the current is generated. Once again, they say that the coil is rotated, right? This is AC or DC. It's an AC generator. Right, it's an AC generator. Because you're generating the current while you're spinning it rotate externally to generate the current, right? Watch the video from last week. Okay, then after it says that apparatus in figure 10.1 shows a part of the AC generator. What is it connected between A and B? Definitely a slip ring. And then what now? After that, sketch a graph to show the variation of the time. A lot of you guys are very tempted to draw a sine graph, guys. Is it going to be a sine graph or is it going to be a cos graph? Why? Yeah. Guys, listen if you draw a sine graph, you're basically indicating that at this exact instance here, where the coil is moving perpendicularly against the magnetic field, it's going to generate zero current. You get what I mean, right? Because at this point here, it actually generates the maximum amount of current, right? Which actually should be a cos graph. Oh shit, only corresponding to one complete rotation, so you can only draw one graph. Hey, and I see some of you guys drew multiple sine graphs. You're not reading the question properly. Only corresponding to one complete rotation. How many of you guys drew the cross graph? Can I have a... All of you guys drew sine graph. Sine graph. Sine graph although. Sine graph although. Yes, be careful, guys.
But what is question 1? I didn't ask me to repeat. What is the same thing?
What do you mean 1 and 2? Which is 1 and which is 2? Say 2 ways which the... How?
So I'm T corresponding to. So it's actually must be the same thing. Like it's something.
Yeah, absolutely. Don't see and sketch a graph to show the variation. Yeah, this should be a key.
Oh, wait. So if you were to draw 7, even for the top.
Yeah, I guess that would be acceptable as well. Got it right. Maybe you need to draw more than one graph.
So you
Yeah, just draw one. Good enough for you. Okay, then after that, state 2 ways, which the graph would be different if the spin of the coil is faster. What's going to happen? Good, there'll be a higher frequency. So if let's say I were to draw a different graph, right, with a higher spin rate, it'll look something like this, right? Because I'm spinning faster, right? What else would be different? Wavelength and frequency are interrelated. Good, the amplitude will be greater also because I'm cutting through more magnetic field, so I'm generating a larger current. Very good, Charles, for someone who did not come. Yeah, so you're supposed to say the frequency of the graph. Okay, simplify it. There will be more oscillation with the graph or the the results already. Still not yet for River 6. How much? Oh, very good. 61 is the threshold you should be aiming for out of 80. Like I said, for people 4, 60 out of 80 is a very good threshold to aim for. And that will guarantee you an A in your real IGs. Did everyone tell me the paper 4 already? How much? Okay, very close. Not too far away. Okay, very close. A little bit far away. Huh? Very far away. You? 54 to 56. Oh, so you're 56. Okay. Okay, not too far away. Your paper 4, you need to work a little bit more for yours because it's a bit far away for you. But I expected you to be higher though, actually, for your paper 4. What happened? Your paper 2 was so strong. And they say paper 2 was the hardest one, right? Huh? No way. Everyone said that paper 2 was hardest.
Apparently not. Apparently not.
6. Dare I ask a question next week? Let me know next week, guys. Your paper 6. Okay, anyways, suggest what could be connected to CNR so that the current R is always in the same direction. Was it same direction? Huh? It's called a diode. No need to overcomplicate it. A diode is good enough. Okay, last question before we do the last chapter. Sorry, what? What? No, ignore it. It's a cost graph for sure. Sui. Okay, anyways, a circuit contains a battery, a variable resistor, and a solenoid. Figure 9 below shows the magnetic field pattern produced by the current in the solenoid here. State how the magnetic field pattern indicates region where the magnetic field is the strongest. How do I know which part is the strongest and why? Yeah, when the magnetic field are the densest together, I mean to say these two parts are the strongest. Alternatively, these two parts is the weakest. Right, when the magnetic field are the closest together or the densest together, they are the strongest part of the magnet. When the magnetic field is close together, highly dense or very close or whatever way you want to structure it, basically say that a lot of magnetic field at that region. Sorry, what? So what happens to the magnetic field when the current in the circuit is reversed? Obviously, the magnetic field will. Yeah. Okay, easy. Okay, and then next, the variable resistor is adjusted so that the resistance changes quickly. Hey, what's going to happen? Hey, what's going to happen? If I go from maximum resistance to minimum resistance continuously, like up, down, up, down, up, down across the variable.
One direction.
Yeah, but it's going to be maximum, minimum, maximum, minimum, maximum, minimum. What's gonna happen to the magnetic field first when I have maximum resistance? Very good. So at maximum resistance, because there's a very little current here, the magnetic field will be very small, right? Or be very weak lah. And then at minimum resistance, because there will be larger current here, the magnetic field will be bigger, right? So you can imagine the magnetic field like pulsing, it will keep going to minimum, maximum, minimum, maximum, minimum, maximum. Which, if you notice here, there's a secondary coil connected here, not connected like to the right.
And
on the right side of the coil. So what's going to happen if my magnetic field keeps fluctuating in the first coil? And then there's a secondary coil here. Very good. Guys, this here is an application of how your phones charge magnet, like wirelessly right now. They are basically fluctuating the current in the primary coil, which causes the magnetic field to, can you imagine the magnetic field is like going from small to big, then back to small again, then back to big. Then essentially what's happening here in the secondary coil is that the magnetic field is cutting through the secondary coil, right? Right, which then again, when magnet cuts through the secondary coil, what will be generated here? EMF and current, guys. This is how the wireless technology works in your phone right now. When you place your phone into the wireless technology, you don't even need to charge it anymore because what's happening at the bottom there, right, is that this thing is fluctuating the magnetic field. And when it fluctuates the magnetic field, there will be a receiving coil in your phone that will constantly be fluctuated, and then that will convert it into current that will charge it back into the battery. That's how the wireless technology works for wireless charging. Okay. So having that in mind, then you can answer the question already. The variable resistor is adjusted so that the resistance changes quickly. State and explain what is seen to happen in the circuit in the secondary coil. Then you need to state first all your statement is that the ammeter will deflect continuously. Because what? What's your explanation?
EMF generated by the cutting of the coil by the other solar.
Yeah, you got the right idea. Due to the fluctuation of the magnetic field that constantly cut through the second solenoid, because of the fluctuation of the magnetic solenoid, generating batteries. Okay, then next, the variable resistor is adjusted much more slowly than in one. State and explain the difference in what is seen to happen in the circuit on the second solenoid. What's going to happen right now? Just now I was fluctuating very fast, so obviously the magnetic field keeps pulsing very fast, right, and cuts through the secondary coil. What if I slowly fluctuate it this time? There'll be what? Yeah, less variation of the magnetic field, which means to say there'll be less cutting of the magnetic field from the solenoid, and thus the current generated will be less. Yeah. Yeah, so ammeter detects a smaller reading because of the lower rate of cutting. Okay, everyone? Oh. Okay, next. Finally. Hey guys, you can expect a test next week or next week. Oh, by the way, have we told you yet? Class will only be for 2 weeks on December. You need to say 16 onwards, you're a free man. There's only 2 classes on December. Huh? Oh, I'm going to take a break.
Are you okay with that?
I've been thinking about it. Yeah, but usually December we will take only 2 weeks after that, and then like the last 2 weeks is usually holiday. But so happened this year, the December, there's 5 Saturdays, so there's gonna be 3 weeks holidays for you guys. And when I say 3, I mean the classes will be conducted until the 15th, guys. Is it 15 or 14? I think it's 14. Yeah, I think it's going to be until 14. So those who attend the Thursday class, you'll still have to attend the last day here, right? But for Saturday, since there's 5 weekends, will only until be 9 to me. 16, 23, and 30. Merry Christmas to you all. Enjoy. Yes. Okay. So please let your parents know, guys. And those who come on the 3rd week, enjoy the sign outside. The doors will not be open. Okay, guys. Last part of the day before we end fast. Guys, basically today we're going to learn about Transformers, and when I talk about Transformers, no, it's not Auto. It's not the Autobots, it's not the Decepticons, it's definitely not the Optimus Prime that I showed you in last week's video. Okay, it's basically this thing here. Okay, the most common Transformer that you see that is visible is this thing here. Yeah. Okay, so why do we need a Transformer? It's because, as you notice, guys, all these sockets on the wall, right, they actually provide 240 volts. And we plug in literally all our electrical devices. Your projector lah, your computer lah, your fridge lah, your aircon lah, your phone chargers lah. And we know for a fact that your phone and your laptop don't really need 240 volts, right? So we need something to adjust the 240 volts to the designated voltage, which a resistor will lower the current, which is basically where a transformer kicks in. Okay, so let's say for example today my laptop requires 12 volts only, right? This transformer will convert the 240 volts into the 12 volts where my laptop needs. Your phone charger, the white brick that you put onto the wall, right? That thing is a transformer also. It will convert the 240 volts to maybe your phone's voltage, which is, if I remember correctly, 5 volts only. Okay, transformers basically convert the voltage to the designated voltage of your electrical appliances. And all transformers are different because all electrical devices require a different amount of voltage to be used. Okay, so if you look at the readings here, right, usually they'll say something like what voltage does it convert into from what one? For example, in this transformer here, it will say that it will convert 240 volts into 15 to 20 volts. Let me just throw it on the screen and it'll be better.
Okay, so let's say you have a big roughly and very needs more than 240 volts. Then what?
Good. Then you need a different transformer. You need a step-up transformer. Usually these are step-down transformers. They'll lower down the voltage. But if you need more, you'll need a step-up transformer that will increase the voltage.
So what they amplify?
Not really amplify lah.
It's like another power.
It increases the voltage.
So what? It's like another power source. The blocks are. I think it's the Rothschild taxing your voltage. Rothschild family is taxing my ability to do more.
Shit, this is too small. Okay, good. So you see something like this. Usually they'll have a sticker. They will show you what's being converted. For example, this is in America, I assume, because I don't know. I think it's America because I remember that America uses only 120 volts. if I remember correctly, but don't take my word for it. But anyways, in Malaysia, you'll see that this thing here will be input of 240 volts, right? Which will give you an output of 12 volts, which is most likely going to be a fridge, maybe, for this one, or maybe a TV or whatever. But you can go home and have a look, or you can have this thing around if you're interested. For here, if you look here, it's very, very small, guys. I'll pass this around so you can have a look. You'll see that output is going to be somewhere around 15 to 20 volts, and its input is going to be 100 to 240 volts. You can pass it around if you want to have a look. Sorry? Yes? It depends on how good the transformer is. For example, this one is pretty good transformer. The input range is 100 volts to 240 volts. So you can literally use it in any other countries. But I've experienced this myself. If you use a very shit transformer, right, your whole electrical circuit will fry on you. For example, I once brought, before I used this phone, I was using like a Note 5 Samsung, right? I don't know if I used a shit charger or was it a real charger or whatever it was, but it was definitely designed for Malaysia use only. That thing converts 240 volts to 5 volts. But when I went to Taiwan, right, I remember that input is different. The input voltage was different, and when I charged my phone overnight, right, the next day it still turns on, but something in the circuit fried already because I can't make calls anymore already. Like you can still use like the apps, everything, right? But there'll be no signal coming in already. I assume they fried the signal board or something went wrong. So it's not good one. So like recently a lot of people are traveling more, right? And then they say that, oh, I brought this to charge in Thailand or Taiwan or something, then come back, the thing spoiled already, right? It actually occurs because the transformer is shit. And when transformer is shit, then the electrical circuit will fry. Yes.
I had a question.
Yes.
Oh yeah. So these multi-pin adapters, right? So I assume that what's the maximum amount of sockets you think you can put? Does it like adapt to the voltage?
The maximum amount of sockets that this thing can handle depends on how they build the wires. Because if you think about it, right, all these are parallel, right? So actually, this will be 240, 240, 240, and if they extend it all the way up, it will still be 240, 240 all the way up. But the problem is, how much current can this wire draw safely? Right? Because if the wire is thick, then obviously more current can flow through it, and then it won't be a problem. So usually you see that the more sockets there, right, by right, it should have a thicker wire. But if you buy from some dodgy place, right, you'll notice that they have a lot of sockets, right? But the wire is just the cheap wires. Especially, I don't even know what material they use inside. It could have been non-refined copper or recycled copper or something shit lah. I don't know. Right, but it'll be something shit, then this thing will fry very easy.
Right, but once you start plugging things in, right, then the output gets half.
No,
socket, or everything's the same.
It's the same. It's parallel circuit, what? 240, 240, 240 lah. Right, it will be parallel circuit.
So
the current may change depending on what is being provided here also. Okay, so let's say because in parallel circuit, remember the voltage stays the same one, but the current splits . But most of our time, our electrical devices won't exceed the current that it can supply here. But if let's say you plug a very heavy machinery here and then another one and then another one, then maybe that would be a problem because this thing is not providing enough current for this thing already. You got me? But that's a very good question. Okay, I have my transformer back. Where is it? I want my auto blocks back. Can I have my transformer back?
It's rejected.
Oh, that's sweet.
Follow me, I summon you.
Thank you.
This is my name, guys. Me.
Shut up lah. But yes, that's a very well thought question. Not the Autobots come back and help me protect if they want to. Shut up. Okay, so anyways, like I mentioned, transformers, they convert the 240 volts to your designated voltage of your electrical appliances. How a transformer works is it's basically made of two main parts only. The soft iron core and the coils. A simplified version of a transformer will basically look something like this. This square thing that you see is basically the soft iron core. And the circle things that you see here are known as the primary coil and the secondary coil. Listen up, this transformer is combining the understanding of electromagnetic induction also. That's why I said last chapter. So first and foremost, usually these transformers will only work in an AC power supply. That's why all these things are AC for sure. Okay. This AC power supply means to say that the current will flow like this in the first cycle, and then obviously opposite in the second cycle, right? When there is current flowing in the coil, it will generate a magnetic field, not electric field, a magnetic field. So because the first cycle, the current is like this, right? Maybe the magnetic field is like this, clockwise. And because the second cycle is like this, right? Then obviously the magnetic field will reverse, or it will be anti-clockwise like this. Okay. Now the key point is when it cuts through this secondary coil. Just now I said that the magnetic field, because it's alternating, right? So it will be like a magnetic field that cuts, right? So this is how a transformer works. Because there is a constant cut of magnetic field to the secondary coil, this would eventually generate an EMF and ultimately generate a current here also. Guys, based on the diagram, you should be able to at least imagine or bullshit your way through the whole explanation. Because in a transformer question, a lot of times, I would say 70% of the time, they will ask you to explain how a transformer works. And the question won't be very direct one. It'll be quite weird, but the key thing is you see it's 3 or 4 marks. If it is 3 or 4 marks, right, maybe they will ask you to define what a transformer is. But the question will be tricky. So once again, guys, pay attention. You're supposed to say that AC power supply is connected to the primary coil, right? Which generates an alternating magnetic field in the soft iron core. This alternating magnetic field cuts through, keyword, cuts through the secondary coil, generating an EMF, and then also a current at the end of the day. Okay, who wants to try? Try to explain how a transformer works. Okay, Sean, you explain to me how a transformer works. Starting with AC power supply. Primary coil, bro.
Which causes
Alternating magnetic field that
cuts through the
generating a not current first. What comes first? EMF first, then only there's current. Okay. No, electromotive force is the reason why the current can be driven in the circuit, right? So it's like the car will move without fuel, right? Electromotive force, bro. Electromotive force is like the fuel in the car. Without the fuel, there will be no movement from the car. Without electromotive force, the current cannot flow in the circuit. Try pump lubricant into your car and see if it moves or not. Ladies and gentlemen, Charles. Okay. If anything, I'm Mario. Okay. Who's next? You explain to me again how the whole thing works. AC power supply is connected to the, which generates a what magnetic field? That cuts through, generating a. Okay, very good. One more person. Let's see.
We have to mention the which coil is the current.
Okay, that's a very good question. There's a page later dedicated to that. Hold on to that thought. Natasha, you next explain to me how a transformer works again, starting with AC. Which generates a alternating that generating a very good. Okay, everyone. AC current first, alternating magnetic field, cut through secondary coil, EMF and current is always going to be these. If you structure your words around these, then you know how it works already. Okay, if you look at the statement, it's literally everything I said. Hey, you read through everything I said, it's exactly what I mentioned in a more structured manner only. Okay, but make sure you read through this. And this is basically a rewritten concept which is simplified to help you understand once again. By the way, you'll see in your exam a lot of times they'll say this word known as magnetic flux. Magnetic flux is just a fancy term to say changing magnetic field. It's basically the fluctuation of the magnetic field. If you don't want to write magnetic flux and if it's confusing, just say changing magnetic field or alternating magnetic field. It's good enough already. Because when I was young, I remember hearing this word magnetic flux 1,000 times and I was confused as fuck. I didn't understand until when I reteach it again. If you don't remember it, just say changing magnetic field. Okay. And then after that, we go into the next part, which is a step-up transformer or a step-down transformer. Which because guys, a step-up transformer and step-down transformer works on the principle that we're cutting the magnetic field, right? Which is once again, the more magnetic field we cut, the more current or voltage we can generate, right? That is why, depending on what it is, there'll be more or less turns in the primary coil. For example, if I want to step up the voltage, right, then I'll need to have more turns of coil here because when my magnetic field cuts, I want it to cut through as much as possible, right? Then it will generate a larger voltage. Alternatively, if I want it to have a smaller voltage, I want to step down the voltage. Now I should have less turns here, right? Because when the magnetic field cuts here, there will be less cutting of the magnetic field and thus generating a smaller current, a smaller voltage. Okay, now I want to highlight one thing. Everyone pay attention to this. You may or may not need to use the formula depending on the paper. If it's a paper 2, I suggest don't use the formula because the ratio works faster in the sense that the voltage and the number of turns is the exact same ratio one. For example, if here to here is a multiple of 4, then here to here will be a multiple of 4. Okay, but guys, this is where the exam tricks you up because a lot of students, they remember the ratio is the same, right? Multiply, right? The power is the same, guys. In a transformer, they assume that it's 100% efficient. 100% efficient meaning to say the power in the primary coil is the same as the power in the secondary coil. And if you think about it, right, VI equals to VI, right? That means to say when I have an increase in voltage, like you can see here, I'll have a decrease in current. Means to say here is a divide by 4. A lot of students, they'll dare to write this for me. They'll write here is 40 amperes. Which then I proceed to walk up to them and beat them. Because ultimately, you need to remember that the power is the same. The power is the same. If it's 40 amperes here, then the power won't work. Okay? It is assumed that the power is 100% efficient unless stated otherwise. Sometimes in your question, they'll say that this transformer is only 90% efficient. Meaning to say here only got 900 watts. Okay? If they don't mention, then you must assume that it's 100% efficient. It will be the same power on both sides. Okay? Same thing for this one also. A step-down transformer, the only difference is that the number of turns is different only. Okay, here, if here to here is divide by 4, sorry, divide by 5, here to here is divide by 5. And here to here will be a multiple of 5, because the power is the same.
So let's say the transformer, whatever, is 90%. And 900 watts, which is the voltage still be a multiple of 4.
Yes, the voltage will still be a multiple of 4, but the current will change. Okay? But you'll see the questions later. I've included everything already. Okay, guys. Yeah, you can take your time to read this. It's literally everything I've mentioned already. Please read through it. But in the meantime, copy down the formula after you're done reading through it. And then start attempting the 4 questions on the right.
That's the issue. And things nothing, and things all and things nothing but thoughts. I don't even. I'm sorry.
Oh, yeah, I think that's good for CJ.
Yeah, I'm probably not people who said my theory. Pretty good.
You want to look
When is it? They got what? Oh, yeah.
service.
What?
Check. So,
Very close of you.
there's a like. So, we need other things not. How is it? What? Jeffrey, after you don't get it.
Sure. Okay. Oh, actor. We just read the phone call. Generally, as much as you. In audio budget and I want to, I don't think so, here.
Yeah.
That.
I saw the I saw problems in both the cars. Yeah. I need to do this. What's the number?
Yeah. You know, it's been going really, you know, like box, like oil, and all. Right? Yeah. I'm feeling it's exactly. I would want it, how that is. Yeah, right, school. Right. You know, space, things. And what's that? I think actually, but every time you're important, and very, be hard, better than important thing at the time. It's good. But after that. because that prove the size of them. Then there's a bit, but.
Oh.
Guys, by the way, everything in the back, right? Will be over. One. Oh, and few see five. The 521. So it's a big page. 59. But then the one. Yeah. So we'll give page 59 and everything. What the fuck?
We'll still represent. Hey. You see something. You think something. What else can I think? You stop. He's also an actor. Oh. But he's a big one. Now, this one. But yeah, but and the series actor, but in past in the areas of the lots. Yes, you there yourself. There you go.
You're welcome. You too. Yeah.
4,800 watt.
After one because now it's
This would be, well, yeah, like, getting you guys to know how it's going.
yeah, no,
Oh, it's here. Oh, yeah.
yeah,
How it is.
so I was want to say this
This is, okay, so please.
and this only going for how it's going to be fighting. It's going to be tough.
Go to this key for this. I was just listening to the
Yeah. Yeah, it's going to choose speaking to files. So then, for example, that files are going to kind of configure two of it in clear. That And for question number 4, you get a period for now. We'll talk about this. Both of the calculation questions you guys should be doing. Popular administration. So you get a period question. You will all the next week. Tell me, I'm over the table to maintain. Moving everywhere. The one is not created a boundary on the business. In one message, everything not together. No, I agree. But that's not, I guess. Part of the you will get high certificates and high voltage. Right, there's high tension. There are the. I think they don't reach the wall with people. Well, what? Multiple meeting. Then you put 30 here or 34 and 24 to 30, you get a delay of standard. There's always not and that one increase the transformers. And so there's the thing. So hopefully the house that we use is on home that converts that would be the neighborhood. So it's not like one it's one more per area that we just spread the two bottoms to one. Something with the power. Power can be stored in the area. Next week. Power. With power. With power. Something to do with safety use. And heat loss. Okay guys, like I mentioned, please make sure you do your homework until page 69. Yippee! And next week we will continue on with this last part here. Then we'll be probably doing some revision of paper of electricity. Then the last week before the class ends, I'll be giving you guys exam. Yeah. Guys, on the 9th, it's going to be the test for electricity, guys, on the 9th. Which I will once again have to feedback to your parents along with your marks.